Example 15. Calculate the pH at the equivalence point when 40 milliliters of 0.1 molar NH3 is titrated with 0.2 molar HCl. The Kb of NH3 is 1.8 times 10 to the minus 5. All right, let's start by finding the number of moles that we have at the equivalence point. In order to do that, we have to find the volume of the acid at the equivalence point. So using that MAVA equals MBVB and the given amounts for the base, NH3, and the concentration of the acid, we find that that happens after the addition of 20 milliliters of acid. Using the concentration, 0.2 molar times 0.02 liters, is 0.004 moles of both acid and base. So we set up our neutralization reaction, and we say we have equal number of moles of acid and base that both get used up, neutralized. But in doing so, we create this conjugate acid, NH4+, 0.004 moles in 60 milliliters, which is a concentration of 0.0666 moles per liter. Now, that NH4+ will undergo hydrolysis. Here's the hydrolysis reaction. Okay. So we can create an ice table to think about what happens at equilibrium. We start with a known amount of NH4+. We use some of it to create NH3 and H+. Okay. And we can write a Ka expression. This is an acid. So we have to write a Ka expression. We're only given Kb for NH3, so we have to find Ka. It's 1 times 10 to the minus 14th over 1.8 times 10 to the minus 5, 5.56 times 10 to the minus 10th, which is equal to the concentration of the products, X times X, over the concentration of the reactant, 0.0666. We solve for X, which is the hydrogen ion concentration, and we get a pH of 5.22. So I titrated a weak base with a strong acid, and I got a pH that was slightly less than 7, so slightly acidic.